Hello everyone. In today's tutorial, we'll be covering the topic of action fighting combat. We'll achieve the results you can see in the video right now. Before continuing with this tutorial, I recommend you watch my previous one to set up the custom camera and target lock, although you should be fine following this tutorial without those systems in place. We'll need two things before we get started, an input controller and the player character controller. I'll leave links with timestamps if you need help creating those, but they're pretty simple to set up. The input controller simply tracks our player's input and, based off that, fires the corresponding events. To start off, we'll have to create a new bindable event. I'll call it primary attack event. First, we'll get a reference to that event in our input controller script, and we'll fire that event inside our input began function. Since I already have some logic inside this, I will just add an else if statement after the keyboard input check. All we do is check if the user input type is mouse button 1, which should fire our primary attack event. And that's all we have to do inside this script. Next, I'll explain what my player character controller script does. Inside it, I have two events. One that fires when the player's character is spawned, and the other when it dies. It's another very simple script, so I'll leave a link with the timestamp in the description that explains it in more detail. Next, we'll need our combat animations. I will create 4 animations, each part of the combo chain. While creating your animations, we have to do one important step for each of them. At the keyframe in your animation where you would like the damage to be dealt, we have to create an animation event. In my case, I call it primary attack peak. It's very important you do this and remember what the name of the event is. You have to do this for all your combo animations. Alright, now that we have our animations ready and published, we'll have to create our animation objects. I will do it inside replicated first with subfolders. So just create the animation objects and apply the animation IDs. Now we can get to scripting. Create a new local script in our starter player scripts folder. Call it combat controller. First, we'll get references to our character spawn and death events, and also we need the primary attack input event. We can now create the listener functions for these events. Keep in mind that the character spawned event has a parameter, which is our new character that spawned. And we can create a start function where we'll bind the functions to the events. Now we need to cache our character-related variables. We create references to the character, humanoid, animator, and humanoid root part. We default all of them to nil. Inside our character death function, we set all of those to nil. And inside the character spawn function, we'll assign them using our new character parameter. After that, we'll need to cache the replicated first folder. We also need to track our loaded animations, so we create a new empty table called attack animations. Create a new function that's going to load all our attack animations when the character spawns. First, we do a null check on the animator. After that, we set the attack animations table to empty just to be safe. And now we iterate all of our animations in the replicated first folder and insert them into our animations table. We call this function right after we cache all our character parts. Now we need a few new variables, one that will track if we're currently playing an attack animation, default it to false. Also, we need to track which combo animation we want to play currently, and what the maximum is. I have 4 animations, so I default it to 4. Inside our primary attack input function, we first do a couple of checks to make sure our character is spawned and alive. Then we check if we're currently in an attack animation. And after those checks, we'll reset out current combo if it's less than 1 or higher than our max combo value. Then we just play the animation and increase the current combo. We also got to make sure we set in attack animation to true. Alright, now we have to create logic that will track our animation's endings. First, we create an animation stopped connection variable and default it to nil. Then we need a function that will fire when our attack animations finish playing. And now we go inside the primary attack input function, and in the in-attack animation check, we add an additional statement that makes sure this new connection variable is nil. And right after we play the animation, we'll bind the attack animation ended function to our animation ended event. We also cache it as that connection we just made. Also make sure that inside the character death function, we disconnect and clear that connection if it exists. Great. Now inside our attack animation ended function, we once again disconnect and clear that connection. And we also set our in-attack animation variable to false. We can do a quick test now. As you can see, we can spam the attack, and the next combo can only start once the current animation is finished. One thing I'd like to change is that our character isn't rotating towards where our camera is pointed when we attack. So to do that, we'll open the combat controller script back up. We need a reference to the run service. Then we create an update function, and we bind it to the heartbeat event in our start function. Inside the update function, first we check if we're playing an attack animation currently. We'll also do a few checks to make sure our character exists and is alive. After the checks, we can define the camera look vector on the XZ plane, but for that, of course, we need a reference to the camera. And now we can just rotate our humanoid root part to always face the direction of that look vector. We do a quick test, and you can see the character now rotates when I attack. Great. Now we'll have to set up the logic for actually doing damage with our attacks. To do that, we'll need another connection similar to the animation ended, but this time we'll use those animation events we made. I call this one peak connection, and I also default it to nil. Next, we need a function for this connection. We'll do another null check inside the primary attack input if statement for that connection. And similarly to our attack ended connection, we'll bind the function to our custom animation event we named primary attack peak, and also cache that as that connection. As we did with the animation ended connection, we'll disconnect and clear the peak connection in our character death function. Alright, now before we actually code our attack peak function to request damage dealing, we first need to create a new collision group. I'll just call it humanoid root part, leave its collision properties as they are. Now this is the NPC I've been testing on. Very important thing is to change the humanoid root parts collision group to that new collision group we just made, like this. The spelling is very important here. Back to the script. Now the reason we made that collision group is because we'll be using block casting. Block casting, or shape casting, works similarly to ray casting, but instead of casting a ray, you cast a shape in a direction. And one of the parameters of ray casting is actually the collision group, and that's why we made it. This will make our code more performant. So we create a little helper function, call it blockCastAll. This function will return all possible enemies we can damage that are in front and close enough to our character. First thing we need is an empty table called blacklist. This will determine which parts and their descendants the raycast will ignore. Right after defining it, we'll add our own character to that blacklist. Then we have to define the blockcast parameters. We do it the same way we make raycast parameters. We'll set the collision group to the one we made. Make sure to spell it correctly. Then we'll set the filter type to exclude since we have a blacklist and not a whitelist. After that, we set the filter instances to our blacklist. Now we need to define the origin of our blockcast. I'll set it to our humanoid root part. Next, we need the size of the blockcast. I'll make it double the height and width of my humanoid root part. We also need the direction of the blockcast, which is just going to be my humanoid root part's look vector unit vector, and the distance the blockcast will cover. Then we cache a new empty table called possible target humanoids. This will be the return value of this function. But before we return it, we have to populate the table. We do that in a repeat loop. First, we'll do a block cast, using the values we defined earlier as the parameters. After the block cast, it's very important we do this if statement, as once this is false, it will break our repeat loop. We know because of our collision group setup, we only hit humanoid root parts with this cast, so we cache the cast instance as hit humanoid root part. After the null check on the instance, we'll cache the parent of our hit humanoid root part as hit character. Right after we cache that character, we have to add it to our blacklist. Then we update the blockcast parameters filter with the new blacklist. Very important step. This prevents us from getting stuck in this repeat loop infinitely. Once our blacklist is updated, we can attempt to get the humanoid of the hit character, do a null check and health check on it. If the humanoid exists and is alive, we add it to the possible targets table. Now the condition for our repeat loop to break is going to be defined after this until statement. So here we just check if our blockcast result is nil, and you can also optionally add an OR statement and define the max amount of targets you can damage with a single attack. I'll go with an upper limit of 8. Great, and we're done with that function. Once called, it will return a table of humanoids in front of our character that we can deal damage to. Let's now go into our attack animation peak function. First, we'll disconnect and clear the peak connection. We'll also do an attack animation check. Then we'll make sure everything is okay with our character. After that, we'll call upon our blockcast function and cache the return value as targets. Then do a null check and member count check on that targets table. Now, the reason we have so many checks and redundancy here is because once we pass all those checks, we'll make a call to a server event, and you always want to protect those as they're potentially exploitable. Alright, let's now create a new remote event inside our replicated storage. Remote events allow communication between client and server scripts. So we'll fire the event in our combat controller, and the event callback will be inside a server script. First, we'll need references to replicated storage and that primary attack request event. After that, and after all the checks inside the attack peak function, we'll fire that new event with our targets as the parameter. Awesome. We're done with the client logic for now. Let's create a new server script inside server script service. I call it player primary attack. I will also create a new number value inside the server storage called primary attack cooldown. Leave it as default for now. Inside the server script, we first define our player service. Then we'll need a function that will bind to the player added event. The parameter is going to be the new player. Inside a start function, I'll bind that function to the player added event. Once the player connects, we'll need to define our data structure. Create a folder called combat and set its parent to be the new player. Create another folder called data, and its parents will be that combat folder we just made. Lastly, we need a Boolean value called inAttack cooldown. It will default to false, and we set its parent to be the data folder. If I run the game and open my player object, you'll see the value in the folders. Great, now we can move on to actually dealing damage. First, we have to get a reference to replicated storage. We also need a reference to that player primary attack request event. We'll also get references to the server storage and that cooldown number value. The reason we have this hard-coded number value is because we want to prevent exploiting. Its main use is a sanity check for the server. In case a player gets around the animation ended limitations, we don't want them to be able to deal damage rapidly, so we set a hard time value limit. In my case, I will set the cooldown to 0.5 seconds. This means that no matter what happens, the player can only deal damage every half a second. There's many creative ways you can prevent this kind of exploiting, and the attack cooldown is only one of them. I will show another one in this video. Keep in mind, these are very basic exploit preventions, but they go a long way. You can create more complex ones, but I'm trying to keep it as simple as can be. Alright, now we're ready to do the damage dealing logic. First, we need a new function that will bind to the primary attack request event. The parameters are player and targets. We'll quickly bind this function to the event inside the start function. Now you might be wondering, why is there two parameters to that function, even though we're only sending the targets via the event? This is a Roblox feature, and it does this on its own. Whenever a local script calls fire server on a remote event, the first parameter on the server-side callback is always the player without defining it in the fire server call. The reason why is because Roblox has to have a reference to which player made the call, so it's unnecessary to send the local player as the first parameter in the fire server call. Alright, now before we deal the damage to our targets, we'll do a couple more sanity checks for the server. we'll make sure the target count is greater than 0. We'll also make sure that the player who requested dealing the damage has a character and that it's alive. Then we'll cache our player's current position. We'll also cache a new variable called damaged count and default it to 0. Now we'll use the in-attack cooldown boolean we made earlier. With this value, we'll make sure the player hasn't attacked in the last half a second or whatever cooldown you set. So we'll cache that value and do a check right after checking the target count. After all the checks and caching what we need, we'll create a for loop. Inside the loop, we'll iterate over the targets and do the necessary sanity checks before we deal damage to them. Notice the position magnitude check. This is similar to our cooldown check. It's just to make sure the player isn't too far away from the humanoids it's trying to damage. Hey guys, this is me in the future. I made an error here. It's supposed to say continue instead of return in this line. After those checks, we'll change the target's damage and increase the damage count value by 1. Right after the for loop, we'll make sure we actually did damage to some targets with the damage count value. And if we did do damage, we'll set the in cooldown value to true. This means the player now has to wait before dealing damage again. Alright, now we have to create a function that will wait until our cooldown has passed, and then it will reset the player's in attack cooldown value to false. The trick is that we have to wait for the specified time, without pausing the main thread, which should always be listening to the attack request event. So we'll define a new function, primary attack request CRT. The CRT stands for coroutine. It enables us to use the wait function without pausing the main thread. And right after the wait function, we'll make sure the player still exists. And if he does, we set that in attack cooldown value to false. Now to actually call this function after we deal our damage, we have to wrap it as a coroutine like this. Notice the parameter is defined in parentheses outside the function wrap call. I made an error, so before we test our damage, let's go back into our combat controller. Right here where we block cast, I used a dot operator instead of the colon, so fix that real quick. And now we can test the damage. As you can see, everything works as expected. Now we're pretty much done. I'll also quickly add a VFX once the damage is dealt. Pretty easy to do, so I'll just fast forward. We call the emit of this VFX inside our combat controller script after we fire the remote event. And we're done. We have a pretty solid and simple combat system which can be expanded upon. This tutorial is the second part of my action combat tutorial series, so stay tuned for more, guys. If you run into any issues, need help, or just want to chill with other developers, join my Discord in the description. Let me know what you think in the comments. Leave a like or subscribe if you want to. That's it. Thanks for watching.